phase 2 of DCS Harmony is taking the data that we get from analysis and from running the emulation and all that, and trying to use it to make Helios interfaces or make Helios interfaces better. So like I said, our input is DCS BIOS interfaces, and they look kind of like this. So it's a Lua file, just this is the MI24P. So just as a bunch of what we call functions. So each function is just declared here. It says like, okay, I've got this thing. It's the right engine mode indicator. It's a float. I give it a name. Say where to get it in the DCS interface, what its range is, and what category it should go under, which is engine gauges. And it just goes on and on and on and on and on. And if you've used the 24P, it's got like 1,000 buttons. I mean, that's not far off because, there's like 1,200 lines of code here. So maybe like 800 buttons, 900 buttons, something like, I think there's 900 and, actually wait, I know this number because I tested it the other day. I think it's 961 defined functions. And each one of those required a human being, in this case probably Warlord, to figure it out in the DCS Lua code and write this and get it exactly right and get it exactly correct. So we don't want to duplicate that effort, so we want to leverage that. However, this kind of file doesn't run in a Helios export system. You might ask why not. I actually did that at one point. Last year I wrote a thing for Helios, not a release thing, but just something I wanted to try out to see how it would go, to run the DCS BIOS modules directly. And it works ish. I mean, you get data out, but because the Helios, the Helios interfaces are a bit different from the DCS BIOS interfaces in that we do, we assign units to things, we scale things, like, we don't tell you, the needle on the indicated airspeed is at position 0.35. We tell you it's, 120 knots. So just running it is sort of not sufficient for us. So instead, like I described in the previous menu, in the previous video, I extract all the knowledge that is in here by running it in an emulator and capturing all the data, and I get something like that, like a big file that just says like, everything I know about that thing, right? And about each function. And then I put that in my database. And then the next step is to try to create a Helios interface. So wrote some programs to do some translations, proprietary programs, and I get something like this. So this file now is the same interface written as a JSON file in a more Helios way. So it says like which Helios class to use, what piece of C# code to use, how to configure it, all the, like for example, for the site doors, right? We want to get, we get it from DCS at position 775. That was in the information. And it has two positions, 1 and 2. But, they haven't been named yet, right? They're just called position 1 and 2. But, at least it's something, right? So we would probably want whatever these two positions to be, whatever they mean, we would probably want that in here. So we want to rename that. In Helios, it's okay. We can rename that later because it, the name is sort of only for the UI. So we can call it like open and closed or whatever the heck this button does. I don't actually know what that button does because I don't use this aircraft. But the point is that somebody could go back and go back to this file and call it open and closed instead, and then it would be all nice in the UI. But either way, we now have a file that is pretty close to the C# code that we would need to implement this interface. And then there will be some things that the translator can't figure out. And then it'll just say like, this is unimplemented. So for example, their arc frequency L on the ARC15 operator side is a callback Lua function in the DCS BIOS interface, and my translator doesn't currently yet understand it, so it just says there's this thing, it's gonna need attention, it's unimplemented in the sense that I don't know how to translate this to Helios. You're gonna have to do it. So at that point, a person would need to contribute this specific function. But as it turns out, the vast majority, like hundreds and hundreds and hundreds of functions in here, are just a switch. It's like a 3-position switch, it's a 2-position switch, it's a rotary, it's a potentiometer, it's a rotary encoder, whatever. It's something like that we do understand. So the vast majority of things we have. Now, how do we get this into code? With Helios 1.63, you can't. Because in Helios, like I mentioned before, interfaces are written by programmers in C#. Started a project sometime last year, I think, again, or not sure exactly when it started, but it was a lot of work. I changed Helios to where you can also define interfaces in a JSON file that can be edited. So it would just be on disk. Even a user or a profile developer could go and change something if something is wrong in the actual DCS interface, and change the definition, and Helios will read it and will define it without needing any C# code. That piece is the labs content. So, like I mentioned in the introduction to this series, things in this, when you see the little labs warning in the corner of the video, it means I'm not committed to shipping it. This particular thing, I'm actually trying to ship. It's currently, being developed for release on 1.6, and it's looking pretty good. So I believe we can get this out. We're on the way. Okay. So what that means is that these translated interfaces will just work in Helios. They won't be 100% complete, right? But instead of somebody like Captain Zeno or whoever else, if anybody else ever actually did it, which hasn't happened so far, I think, at least not recently, did a new interface from scratch, they would get a good head start. Out of the 961 functions, 940 of them will be already implemented for you. And you just have to do a little bit of work on those few that are weird, or just don't do it. And then those 5 switches or 20 switches or whatever just won't work yet. Either way, you'll be able to, have an interface that is fully declared and has names and everything, and is easy to use in Helios, as we will see in another video that I will go make now.